Good morning. My name is Shan McAdoo. I'm the Senior Vice President of Software Development at Eumonics, and I'm here today to talk about the Eumonics platform and architecture. Here at Eumonics, we are building a state-of-the-art internet-based software as a service and data as a service architecture that allows us to ingest and manage petabytes worth of data on a daily basis. So for example, we have many different types of data that we bring in. We bring in stock data, options data separately, cryptocurrency data, consumer packaged goods data, climate data, and sentiment data, among the many different kinds of data. We additionally bring in data from government resources like FRED, the Federal Economic Data, on a periodic basis. This means that we have petabytes worth of data that we ingest on an ongoing basis. Well, in order to do that, we have had to build a state-of-the-art technology stack that we can use to keep that data fresh and current and manageable by machine, not by human beings. Before I get into the details of our stack, I want to just describe a little bit about how data gets processed and the history of where that came from. So back in the first generation of the internet, I would go out and I would buy a server and I would put it in my server room and I would configure it, and it would serve megabytes worth of data, maybe as much as a terabyte worth of data. And that would be me running an early version of a website that had some content attached to it. And that worked out pretty well. I had the server on a rack in my server room. Worked out pretty well. If there was a hardware problem with the server, it was my problem to deal with. I might have had a backup server. I might have had some kind of redundancy capability, but it was all housed in my server room. Then the world moved on, and we moved into a world where all of that became virtualized. And I could go to a giant provider, Google Compute, AWS, Microsoft Azure, and they would make virtual machines readily available to me that I could just configure and spin up my own virtual private cloud as easily as I wanted to. But it mimicked the reality that people had seen before. It was basically me building a virtual version of my server room. So I would have an application server and a database server, and I would have a load balancer, and I had all of those things in the virtual private cloud that I managed manually. And that worked out pretty well. Because I had all of that virtual capability, I could scale things up. I could create different kinds of configurations of my virtual private cloud. It allowed me to do a lot, but I was still doing it all manually. It allowed me to scale up, but it didn't quite get all the way to the internet scale that we see pretty much across the board today. Now, in the nth generation, all right, I'm serving dozens or hundreds of VMs that I am building through code, infrastructure as code, on the fly. It's all happening very quickly, and it's allowing me to serve terabytes or petabytes worth of data with a minimum of staff and an internet architecture that allows me to ingest, process, and then put out as product literally petabytes worth of data on a daily basis. This is the revolution. This is brought to you by the Internet of Things. Now that everybody has a sensor on their wrist that's recording all of their biometrics and reporting it back to the server, what am I going to do with all of that data? How do I move that data fast enough so that somebody can turn it into something meaningful? Well, this nth generation architecture that we're talking about is how you do that. That is what we've built here at Eumonics. Our architecture consists of 3 levels. First thing we have is what we call the compute platform level. This consists of an internet service provider like AWS or Azure. They provide us with all of the virtual machines we need, et cetera, et cetera, et cetera. On top of that, we layer Docker, that's that beautiful little whale icon, and then the ship's wheel is something called Kubernetes. These tools are used to allow us to build infrastructure as code and instantiate it very, very quickly. So I can literally say, run a script and create hundreds and hundreds of virtual machines on the fly to process a giant batch of data. Once that data is processed, all of that infrastructure immediately disappears. So I only pay for the infrastructure for the time that I need it. AWS, Azure, all of the compute clouds allow you to do this using tools like Docker to create beautiful images of the machines you need, and Kubernetes to create a control plane to allow you to instantiate those pods and turn them on and off as necessary. I can make it happen very quickly. Then on top of that, we've layered a series of tools that allow us to quickly process data. The left-hand icon is something called Airflow. Airflow allows us to orchestrate data ingestion jobs on a giant scale. I can have literally thousands of different data ingestion jobs that are quickly managed through the Airflow interface. Next to that is the Snowflake icon. Snowflake has become the de facto platform for database as a service. It's a very easy tool to use because what it allows me to do is all of those relational database operations that I grew up doing with Oracle or MySQL or any other of those normal SQL platforms that I had to manage the backend infrastructure for is now managed by Snowflake as a service, and it automatically scales. So when I have a big Snowflake job to process, I don't have to worry about spinning up a giant box to do it. Snowflake does that for me automatically. Same thing with the next icon, that's called stream sets. For textual and binary data, I can process at scale any giant batch of data that I want using stream sets, and it will automatically scale as necessary. And then finally, I have dbt and Kafka as ETL components. dbt is a SQL cataloging tool and a code cataloging tool that allows me to have tens of thousands of different data jobs oriented and organized in a manageable fashion. It makes the work of hundreds of programmers into the work of a single programmer. And then finally, Kafka. Kafka is the messaging tool that ties it all together. Because when you create a compute platform that allows you to scale up horizontally, you need a way for all of these new virtual machines to talk to one another. So the master node can talk to the worker nodes and say, here, go do all of this work. Kafka is the messaging tool that sits between all of these machines and gets the work and does the work of dividing and conquer. That's how this goes. Finally, we layer on top of that what we call our presentation layer, because we have now industrial strength ingest ETL capabilities. We can process petabytes worth of data, but now I have to make it so that the end user has a very meaningful and rich, quick experience. How does that work? Well, on the left-hand side, we have GraphQL. GraphQL for structured data is an in-memory data repository. That allows me to quickly render any kind of data at scale for the end user that comes in what you might think of as a structured format. So think rows and columns, right? At the lowest level, you would think of a spreadsheet, right? Rows and columns. And then you might think of what you might get in a relational database. Well, GraphQL is an in-memory version of that can service a user interface at scale with literally tens of thousands of megabytes, petabytes of data served in memory very, very quickly in milliseconds. Same thing, the icon next door is Elastic. Elastic is a derived version of an open source full text search engine. Elastic allows me to process and manage thousands and millions and petabytes worth of full text data and then serve it up to the end user. So with GraphQL, I'm bringing up structured data. With Elastic, I'm handling unstructured data, giant corpuses of text. Read all of the ongoing research, all of the ongoing medical research that's happening on a daily basis, a yearly basis, or whatever, make it searchable for me. Elastic can do that. Furthermore, Elastic has capabilities of handling binary data. So for example, upload a bunch of image data and make it so that it is also searchable based on binary capabilities. Elastic is an engine that supports that. Finally, I have the ability to render an interface using tools like AmCharts and D3. That makes us quickly able to create beautiful interfaces that perform at a high capacity, that make things very, very happy for the end user. So finally, I want to just demonstrate a couple of things. I want to show you our Airflow interface. This is a list of jobs that are currently running on a daily basis that are ingesting data on an ongoing basis. As you can see, there's literally hundreds of jobs, and they all work flawlessly, seamlessly. I get reports and logging. I don't have to manage that manually. It's all taken care of for me. And then finally, I want to show you what the data might look like in the end user interface. Here, I'm just going to quickly render a graph. I just want to see a picture of Apple stock. There's Apple, and I've rendered it very quickly. And in fact, not only did I render Apple on a monthly basis, but let's change things up a little bit. Let's render Apple on a daily basis. So we'll go back and we'll render Apple. We're going to look at all of the Apple, every instance of Apple data on a daily basis for the last 9 years. As you can see, tremendous amount of work goes into this. And as I zoom in, the data becomes more and more viewable and scales up. And it's happening instantaneously. This is what GraphQL is doing for me. It's helping me render the data from, literally tens of thousands of instances down to very quick instances in milliseconds rather than waiting time. So thank you for your time. If you have any questions, feel free to reach out to Shan McAdoo at eumonics.com. And I appreciate your attention.